All right. So in this one, we'll talk about the types of problems in the quantitative analysis section. And so most of the time, you're finding the concentration or volume of it, of something. And so it's similar to the limiting reagent type calculation. But the difference is, so the two main types that we have are titration and gravimetric analysis. And so the end result is the same. They're both just aqueous solution mixed with the aqueous solution. The difference is that titration produces a salt and water versus gravimetric produces a solid and potassium nitrate or in a salt. So and so in both cases, then we use the known volume and concentration one to solve for the other one. And so that's what I'll kind of show. And so this is the kind of flow chart that I always show. And so we started with basic balancing, moles of A to moles of B, and then we started adding in grams, and then we got to the big finale in the earlier chapters, going from grams of A to grams of B. And so now we're doing a similar type thing, except we're going from concentration to concentration. So going forwards and backwards. So if you can visualize this, I think it helps you a lot. And so in the first example here, what's the molarity of a barium hydroxide solution if 25.3 milliliters of 0.135 molar HCl is needed to neutralize 15.3 milliliters of barium hydroxide? So a lot of numbers, and then how do you keep it organized? Well, first you got to start to do the balance equation. All right. Sometimes you're given it, sometimes you're not. So you have to put the reaction in, and then you have to balance it. And the main thing is getting this mole to mole ratio. All right. We don't really use the products, but okay, the second thing, I always kind of orient myself, and it's not really necessary, but these two, you're hopefully see the similarities in it. And so um, the main idea is that we're going to have to get to moles, right? That's what we saw in that flow chart. And so we're just thinking about what all the information we're given, and then only one species, we have a volume and a concentration, so that allows us to solve for moles of it. And that's the most important thing to do, to organize the kind of numbers and think about the pathway. And so this form factor here is what we usually show in the second semester under ICE, initial change in equilibrium. But I like this to help to find which one do you know. And so if we do volume times concentration, we can get moles. And in this example, I kept it in milliliters to show you millimoles. That milli just commutes through. And we can do the same mole to mole conversion. And now we have millimoles over milliliters. So when we divide that, we can see the millis cancel and give us just the normal molarity. Another way is just like the full dimensional analysis. So we have the molarity in the volume, so we can get moles, and then we can do mole to moles, and then those moles over the volume to get molarity back out. So either way works, and the main thing is, again, visualizing those steps. The second type of problem is going to be the exact same kind of pathway for it. And so in here, what volume of KCl is required to completely react with 0.175 liters of this molarity of lead nitrate? And so again, we need to write the balanced equation. And so KCl PbNO3 swapping. And so you have some clues here. So if you remember the polyatomic ions, nitrate is -1. So since you're swapping with KCl, which is -1, that 2 remains the same. So little tips there to help you. And once we have this, again, I always kind of connect it back with the experiment. That's not really important. The main thing, again, is just to match what you know and how can, it's like a puzzle. How can you move forward? And so this is the one where we know volume and concentration, so we can get the moles of it. And again, use a balanced equation. And now that we know moles and molarity, we can solve for volume. Okay, another way is to do the full dimensional analysis to get the moles of it. And again, like I said, we know the concentration equals moles over volume. So now you can solve for the volume in liters. Okay, so those are the last ones, and I'll just kind of take this point to kind of remind you a common kind of calculation then is going to be the precipitation, like the limiting reagent lab. It's not under quantitative analysis, but this is the same basic idea, is that we're going to take two solutions and we're going to figure out which one produces the least amount of product. And so we look in this type of problem, if we're given a volume and a concentration for both species, so that's your kind of clue that if you have a volume and concentration, and then it asks how much product, that's where you're going to have these competing pathways. All right. So again, same starting point. You have a volume and concentration. We get to moles of something, and then we do the mole to mole conversion to go to moles of it. And the thing that's different is since you have volume and concentration for the other one, that's your kind of clue. You have to do it 2 times. All right. I hope that helps.